And if you look, we're just basic properties of parabolas. It says to identify the vertex. First, every single, I don't know if you can read that because that seems kind of small to me. That looks better. Anytime you see y equals and you see something squared, it's going to be a parabola. That's how it all works. And every parabola has a vertex. A parabola is either going to be opening up or it's going to be opening down. How do you know if it's opening up? Whatever is in front of the x squared, if it's positive, it means you have a happy face. If whatever's in front of the x squared is negative, it means you have a sad face. And these first four problems are, how do you find the vertex? Well, how we're going to find the vertex of, and you may remember this, but it may have been a couple of years, a vertex has an x and a y part, right? A vertex, like if you're just looking at just sort of a generic parabola, it's got an x part and it's got a y part. And so I'm going to review how do you find the x and the y part. And the way I'm going to do that is I'm going to do this, I'm going to do problem 2, and then you'll do problem 1. Now, of course, if you already know how to do all this, knock yourself out. Like if this is incredibly boring and you don't want to listen to me, this is what we're doing. If you upload that, right, upload that by Monday, we're fine. But if you don't know how to answer this, you really need to listen. All right, so back to our vertex. Our vertex has an x part and a y part. And the trick to finding the x part is this little formula. So the x part is negative b over 2a. If you look at that and you think, it may sound familiar, okay? So you have negative b over 2a. So what are the a and the b? Well, this is the a, this is the b, and this is the c. And honestly, we're not going to talk about c for a while, so it's really just the a and the b. So if I want to find out the x part of my vertex, it's negative b. So if my b is this thing, so the opposite of this thing is going to be 4. So my x value is going to be 4 over 2 times whatever this thing is, which is 2 times 2. I just found out my x value is 1. So I found out my x value is 1. Yay. Now, for my vertex, it's got an x part and a y part. I know the x part's 1. Now I need to find the y part. Now, here's how you find a y part. Pretty much, here's how you find the y part of anything. It could be a parabola, it could be a line, it could be all sorts of weird stuff that we're going to graph next month. How do you find the y part is you have a formula. This little formula says y equals all this stuff. I want you to imagine you're doing a little xy chart where you plug 1 in for x. And when you plug 1 in for x, I want to figure out what the y is. So when I plug 1 in for x, that's going to give us 2 times 1 squared minus 4 times 1 minus 2. So I get 2 minus 4 minus 2. And so I end up with negative 4. So I end up with my vertex is 1, negative 4. And that's how you find your vertex. If I give you, this is called standard form, and I'll worry about that a little bit later. But if it looks like this, where it's x squared, x, and a number, how you find the vertex, first you find the x value, and you have to remember this formula. We're going to talk about where this formula comes from actually a little bit later. Once you find the x value, plug that in and find your y value. So, there's no number in front that understood 1. So, first step, figure out what x is. So negative b is negative 16, or the opposite of this thing, all over 2 times whatever a is, which in this case is 1. Well, that's going to give me a negative 8. So if I'm finding my vertex, the x value is 8. How do I find my y value? I got to plug it in. So when I plug this in, I get 64 plus 128 plus another 64. Oh, whoops, negative 8. So I get 64, get minus 128, and plus 64, I end up with 0. So I find out that my vertex is negative 8, 0. All right, seems, not too bad. Actually, at the risk of being repetitive, last problem from here, I want everyone to do problem 4. I want everybody to look at number 5, right? And on number 5, I want you to find the vertex, right? I want everybody to find the vertex, and when you find the vertex, do the electronic raise your hand. So let's see, the x part's opposite of this, which is 2, all over 2 times this, which is 2. So the x part's 1. Well, if the x part's 1 of, okay, so the x part's 1. When I plug 1 in, I get 1 minus 2 minus 3. I get a negative 4. And so we have our vertex at negative 4, at 1, negative 4. All right, now our goal isn't just to find the vertex. Our goal is to graph. So here's how it works. So if you were able to print it out, great. If not, draw a grid, and we're going to talk about some things. As far as our grid goes, we're going to plot the point 1, negative 4. So 1, negative 4, that's easy. And we're going to talk about what our parabola looks like and how we can come up with our graph. And we need to be pretty accurate about it. Right? Now, here's how we're going to be accurate about it. First, we have to make sure we know which way it's turning. Since this is a positive number, it's a happy face. So I know that my parabola is going to do, it's going to be a happy face. But, is it going to be a wide happy face? Is it going to be a skinny happy face? How do I know? Well, you have to plot. What I want you to do is I want you to plot at least 2 points. And the 2 points are going to be pretty easy. Actually, right now it's 2 points. Later, we're going to add on to where it's like 3. Now, so as far as how we graph this, we look at it and we say, we know this is our vertex. I want to find the easiest point. If right now we're just going to do one other point, and that one other point, the easiest one is going to be the y-intercept. Now, how do you find y-intercepts? How do you find x and y-intercepts? I remember. I remember some teachers would say, okay, if you memorize to find the x-intercept, plug this in plug something in for 0, find the y-intercept, do something else. And it wasn't until I began teaching, I said, well, this is way simpler than memorizing something. Let's say you want to find the y-intercept. So we're going to go back. Let's say you don't know what you're looking for. You're just going to, you're going to plug in 0 for something. I'm going to plug in 0 for x. So if I let x equal 0, well, that's pretty easy to figure out, because when I plug in 0, then I'm left with, all these go away, I end up with y is equal to negative 3. Well, what I just found was the y-intercept. How do I know it's a y-intercept? Y is the only letter that was left, right? If you plug in and the only letter left is x, you just found your x-intercept. But in this case, I found out my y-intercept is negative 3. So if this is the y-axis, so I found my y-intercept is negative 3. We plotted that point. Now, some things about a parabola. It's symmetric. Meaning, if this is your vertex, I want you to imagine there's that imaginary line. It's called the axis of symmetry, but everything on the left is the same as everything on the right. So if you have a dot on the left, that means you're also going to have a dot on the right. And so now we have an idea of what this is going to look like. Now we can't do it for this problem because it's not real nice, and I'm not going to make you do it for this problem. But for this problem, we can. Turns out I want to find the x-intercepts, and that's exactly what we were sort of prepping for the past couple of days. If I want to find the x-intercepts, then what I do is I take this and I plug in 0 for the other thing. So if I plug in 0 for y, I end up with 0 is equal to x squared minus 2x minus 3, and I want to solve. Well, how do you solve that? Well, what we did yesterday and the day before is we do 2 sets of parentheses. We have, this is x minus 3, x plus 1. And I want to know, well, what makes this 0? What makes that 0 is x equals 3. What makes that 0 is x is equal to negative 1. We just found our x-intercepts, meaning at 3, it crosses the x-axis. At negative 1, it crosses the x-axis. So without doing too much work, I actually have an idea of what this parabola looks like. All right? Now, the x-intercepts on this one aren't real nice, so we're not going to do those. But here's what I want you to do. Okay. So we found our vertex was negative 3, negative 1. So we plot it, negative 3, negative 1. Now, the next part, you want to find your, actually, before we find the next part, let's make sure the answer we get makes sense. We want to make sure we know which way this is turning. Well, there's a minus sign, so since it's minus, it should be a sad face. So we want to make sure this thing's flipped down. And the next easiest thing is to find the y-intercept. So what I want everyone to do, find the y-intercept, and then do your best to draw a picture. And once you've got a rough picture, wish I had a remote control for that, you're going to find out that your y-intercept is going to equal, let's see, is negative 10. Technically, you should put 0, comma, negative 10. So I do 0, negative 10. That's about here. And since I'm going to have the exact copy on this side, let's see, I'm 1, 2, 3 away. So I'm going to go 1, 2, 3 away, and then go down to negative 10. And then I'm going to draw my little picture. And now I've got my lovely little parabola, and it's turning down, right? If my y-intercept was over here, I'd have a problem. All right. Now, before I start talking about the next group, like you can kind of see, like questions. The next few questions are dealing with identify the max or the minimum value. When you have a parabola, you have a maximum or minimum value, and whenever you see the words max/min value, that's short for the y value. So sometimes they say y value, but most of the time they just say what's the max and the minimum value. And that's short for y value. So you're looking for the max or the minimum y value. So when I look at these two problems, if I were to ask you what is the max or minimum y value, I'd look at this and say, well, because it's a valley, it has a minimum value, and the minimum y value is negative 4. If I were to look at this problem, because it's got a peak, it's going to have a maximum value, and I'd say, well, what's the maximum y value? Well, the maximum y value is negative 1. So finding that vertex is really important because not only does it help you graph stuff, but based on the picture, you know what your max or your minimum values are. And math teachers like to ask questions about what's your max and minimum value. And since I'm a math teacher, I'm going to do that. So what I want everyone to do, number 7, I want you to, so we go through, we find our vertexes, the vertex is 4, negative 4, so I plot the point 4, negative 4. There's a minus sign, so I know it's turning down. But I have an issue if I want to find the y-intercept. When I plug 0 in, my y-intercept is actually going to be the point 0, negative 20. And good luck plotting negative 20. I mean, that's like way, way down here. And we really can't graph that. So what do you do? Well, sometimes you can't plot the y-intercept because things are ugly. But you still can plot one other point. And how you can plot that one other point is imagine a really small XY chart. And what you want to do is pick an x value that's really close to your vertex. Since the x value is a 4, I'm going to plug in either 3 or 5. I have a feeling the 3 is going to be a little easier to deal with. And so when I plug in the 3, let's see, 3 squared is 9, so I get a minus 9, plus 24 minus 20. So I get minus 29 plus 24, it gives me a negative 5. And so when I plot the point 3, negative 5, I also know, since it's symmetric, whatever's on this side is going to be on this side. And I can do a rough sketch of my graph. So I need a point on either side. How you find it, sometimes you're lucky and the y-intercept is helpful. Sometimes you're not lucky, and it doesn't work. Let's see. Oh, so identify the max or the minimum value. So looking at this, because it's a peak, it's got a max, and my max value is whatever this y value is. So this has a max value of -4 because we are short. We're looking for the y value. And let's talk about this. Because the fractions are ugly, right? Everybody hates the fractions. So how do you handle it? Well, I'll give you a trick. We're still going to do it the same way. Actually, before we approach this, I want to talk about a trick handling layered fractions. Let's say I gave you 3/5 and 2/5. Right? Here's our lovely layered fraction. You can't really see the 3. I give you 3/5 or 2/5. Now, the sort of the official way of dealing with this is anytime you see fraction divided by fraction, well, it means 3/5 divided by 2/5. Well, I know how to handle that. The keep, change, flip thing, or multiply by the reciprocal. So we end up with 3/5 times 5/2, and the 5's cancel. Right? So our answer is just 3/2. And that's kind of what you have to do in Algebra 1. But in Algebra 2, you have some tricks. And if you do this enough, what you're going to find out is that anytime you have a layered fraction where you've got this fraction over this fraction and these denominators are the same, useful trick, of course you don't have to believe me, you can keep doing this, is you can just cross the 5's out and so my answer is going to be 3/2. That's going to be helpful because now when we look at this, negative b, so I get -4/3 all over 2 of these, which is going to give me -2/3. See, now, knowing that little trick, that fraction doesn't seem so scary to me. I can just cross the 3's out. And so then I'm looking at -4/-2, which is going to give me 2. So now I know my x value is 2. Now, how on earth do you find the y value? Because if I plug 2 into this, I'm okay with 2 squared, but then I have to multiply by 1/3. Plug here, then I have to multiply by 4/3. Plug here, I have to multiply by the 16/3. I'm fine, except those 3's, the fractions make my life miserable. So what I'm going to do is cheat. Because I don't like seeing all those fractions. So when I cheat, what I realize is I'm going to factor out, I'm actually going to factor out a -1/3. And when I factor out that -1/3, that's going to give me x squared minus 4x plus 16. And you see if you multiply back, this times this gives me this times this gives me the positive 4/3, this times this gives me the 16. And how does that help me? Well, I only have to deal with the fraction once. Because now when I plug the 2 in, well, let's see, that's 4 minus a plus 16. So I end up with 20 minus 8, which gives me 12. So this whole thing is going to be 12, and now it's times a -1/3. I end up with a -4. And that to me is a whole lot easier to deal with. So let's see, I'm at 2, -4, here's a big dot. It's negative, so I know it's going down. To find my y-intercept, this becomes significantly uglier, and maybe I should have skipped this problem. My y-intercept in this case is whatever that number is. It's going to be 0, -16/3. And so that's a little more than 5. So it's roughly here. And then this one, we'll go over here, do the same thing. And we end up with a parabola that looks like this. And now, if I want to know what's the max or the minimum value, well, the max value is, it has a max, and our max value is going to be -4. max y value equals negative 4. I wouldn't give you anything this ugly on a quiz or a test. And I really wanted to get to these, and I've got about 10 minutes, so this is perfect. So I'm going to skip down. I'm going to do 11, and then you're going to do 14. So I'm going to do this one, and then you're going to do 14. And the rest of this is homework. There's some you can skip. I'm not going to make you do 13. You can go ahead and skip 13. I don't want to torture you with the fractions again. But I definitely want to do 11. So this is kind of pulling a lot of what we've talked about today together. It's asking to identify the vertex, the axis of symmetry, and the max and the minimum value. The good news is we don't have to graph because these numbers, if I just look at this, it looks like these numbers are going to be huge. And so I don't want to have to plot something that numbers are huge. But everything hinges on you finding the vertex. So to identify the vertex, I'll get, so let's do negative b. So the x part is going to be 54 over 2a, which is 2 times 3. So I end up with my x part, let's see, 54 divided by 6 is 9. So my vertex is going to be 9, comma, I've got to find the y value. So I'm going to plug 9 in. Let's see, 9 squared is 81 times 3 minus 54 times 9 plus 241. And I would definitely use a calculator for this. So I am. So 243 minus 54 times 9 plus 241. After all of that, I get a negative 2. And once you find your vertex, all you really need to do is have an idea of what's going on. If I look at this, I see I've got a parabola turning up. Since my parabola is turning up, I know that I've got a minimum value, so I know my minimum value is going to equal minimum y value is negative 2. The only thing I haven't talked about today, but I talked about it on Monday, is what's your axis of symmetry. Well, your axis of symmetry is that imaginary, it's a vertical line, and your axis of symmetry is always going to be x equals. And so in this case, my axis of symmetry is going to be x equals, and it's whatever the x value of your vertex is, which is x equals 9. So here's what I want you to do. Right? I want you to complete this and submit it, like scan it as a PDF. Do the best you can as far as graphing where you're plotting points. But I think this does a pretty good job of giving us a nice overview of a parabola. Monday, I'm going to talk about I'm going to talk about our two versions of the parabola that I'm really concerned about. We basically just talked about standard form. Monday, I'm going to review vertex, and I'm also going to talk about intercept form. And believe it or not, we've actually done 90% of each of those, but that last 10% is really important. So I'll have some activities that we'll do on that. As far as the Khan Academy assignment, don't do that. I didn't get to it. What I do need to do, because I've got 5 minutes, is I meant to actually finish going over your test. So I did not have that ready to go, and I should have.